Okay, so now we're going to look at just a compound gear train. That means we're going to have 4 gears there. So as I click this, there's my driver gear. That's my N. Here's my next gear, it's attached. Here's my third gear. These are on the same axle. So these, you notice, are turning at the same speed. They've put the little white dots on there so you can see the speed they're turning at. And finally, this one. This one is attached to the blue one, and this green one is attached to the yellow one. What you should notice is the bigger gears are turning slower. It's one of the things I like about this little GIF here. You have this picture, so take a second and get it glued in, and then continue with the video. Pause till you're ready. Okay, so here, this is just saying what I said. These are on the same axle, so they're turning at the same speed. And here's the picture you just glued in. It says, first of all, what's the gear ratio between A and B? Whenever it says this, this is in and out. So again, we know the number of teeth on each one of these. So here's out and here's in, and we get a 4. Now it says, what's the gear ratio here? You need to be writing these notes down as you go to each step. Well, here we're looking at C, which is the blue one, and the red one. So this is in, this is out. 20 over 50, 2.5. So what's the gear ratio of the entire train? Well, we just multiply them together. That's what we did on the last couple of slides. We have a gear ratio at each one of these, multiply them together, get the whole train. Okay, finally we have our last picture. Take a minute, glue this one into your notebook. Now this happens to be a belt and pulley. Notice that this is almost exactly like the formulas we were just looking at. The only difference is when we're dealing with belts and pulleys, we don't call it a gear ratio, and we no longer have teeth because belts and pulleys don't have teeth. Other than that, this is exactly the same formula we had before, and notice the variables stand for the same things we had before. So in this picture, which you should glue in and write these notes down, it tells me this is the in and this is the out. So my out over in, diameter 6 over 2. And what happens to the units? They cancel out because those are going to cancel just like we did on the last time. Omega stands for angular velocity, or the speed, rotations per minute. So in over out. Notice again that this one gets flipped upside down compared to the other ones. In is 3 over 10, or 30 over 10. Cancels. And then our torque. It gives our torques right here and right here. Out over in. So we could also have a sprocket and chain system. And in this case, this is what a sprocket and chain system looks like. You're probably familiar with this on a bicycle. It's almost exactly like the belt and pulley, except the belts and pulleys, they don't have the teeth. Guess what? Formula is exactly the same, except now we've added the torques back in there again. So once again, take these notes. Here's my in and out. Write each of these down as you go. Notice again, we don't actually call it gear ratio because these are not actually gears, but we can find the ratio. And finally, you have this little graphic to glue into your notebook for notes, and I just want to talk about it for a second here. And this is the difference between pulleys and sprockets. If you think about a pulley, that's like the pulley that's in your car engine where the belt of your car is. And a sprocket is more like a bicycle. So with a pulley you have a belt, and with a sprocket you have a chain. The bonuses of the pulley is it's quieter and no lubrication is needed, and it's pretty inexpensive. Think about under the hood of your car. You wouldn't want a loud bicycle chain under there going at the speeds that the car goes. And you wouldn't want to have lubrication under the hood of your car because it gets very hot there. So the belt and the pulley allows you to do it without the extra lubrication, and it's pretty inexpensive. It doesn't have to fit together exactly precisely like a bicycle chain. It's just a flat belt, so it's less expensive there. The disadvantage is that it can slip. If you've ever heard a car where the belt is making that squealing noise, the belt is actually slipping against the pulleys there. A sprocket, if you think about your bicycle, it has a chain on it. It doesn't slip as long as it's the right size, but you have a lot greater strength there. There is a higher cost and it does need lubrication. You can grease or oil your bicycle chain, and it can be noisy at times. Okay, that's it for our PowerPoints. Make sure you've got all the notes. Pause and rewind as you need, and then you can start on the activities.